All right, hey there, chemistry students. This is Ms. Rulark, and we are in the second podcast. This is on isotopes. So we're going to talk about how they figured out the mass of each and da da da. Okay, so what is an isotope? An isotope is just atoms of an element that have the same number of protons. Okay, so the atoms of the elements are the same, but they have a different number of neutrons. Let's see if my pen's writing. Oh, it is. Look, it's blue this time. Okay, so it has a different number of neutrons. That's going to be different. If you'll notice here, I have carbon, carbon, carbon. Each one is carbon. It has 6 protons. They all have the same, but they have a different number of neutrons in here, which makes the mass different. All right, so chemical properties of isotopes should stay the same because they have the same number of electrons and protons. However, the thing that's different is their mass. So on the periodic table, we have the atomic mass, and that gives us the weighted average mass of all the atoms in the naturally occurring sample of that element. Okay, so when I say naturally occurring sample, that means it's a weighted average or an average of the isotopes, the naturally occurring isotopes of that element based on their percent abundance. Okay, so it reflects both the mass and the relative abundance of the isotopes as they occur in nature. So the difference between a percent abundance, that's the percent that they are abundant, and then the relative abundance is just not the percentage form, it's the decimal form. All right, so there's 2 ways to represent an isotope. There's one way called the isotope notation, and it would be something like this, 13 and 6. Okay, or you could see it this way. Okay, so here you have the symbol of the element. There's the symbol of the element. You have the atomic number here. And remember from last vodcast that the atomic number is the number of protons. And then the number that's always up top, this is called the mass number. And I told you last vodcast that we would learn about this in this one. Okay, on this one, it just has the symbol and the mass number. And they don't write the atomic number because the atomic number is going to be the same for all carbon atoms. It's always going to be 6. It's always going to be 1 for hydrogen. It's always going to be 7 for nitrogen. So you don't have to guess at it. You just have to look at a periodic table. Okay, but the mass number here, it tells us, remember, the number of protons and the number of neutrons. So if I give you isotope notation, all you have to do is subtract in order to figure out how many neutrons there are. All right, well, the other way that we can represent an isotope would be called hyphen notation. And that is just what it sounds like. So carbon 13, this is carbon 13 because it's carbon with a mass of 13. We would write it as C dash or hyphen 13. And we call it hyphen notation because it has a hyphen in it. We're so sneaky. All right, so the only difference here is that you're writing it dash whatever the mass number is, right? Because this is the symbol and this is the mass number. Now, in hyphen notation, we do not include the atomic number. In an isotope notation, we can. Up to you. You need to know both ways, and you need to be able to use them interchangeably as well. All right, so looking at this, and we know that an isotope, okay, just to recap, an isotope, same number of protons, different number of neutrons, and therefore it has a different mass. So which of the following represents a pair of isotopes? Okay, so first we got to figure out which ones have the same number of protons. Does this have the same number of protons? Nope, can't be that one. Does this have the same number of protons? Yes, it could be this one. We don't care about that. Go away. Okay, sorry. Whatever. All right, this one does have the same number of protons, but let's keep checking just to make sure. Same number of protons? Nope. Same number of protons? Nope. So which one is our isotopes? This one, because it has the same number of protons, different number of neutrons. All right. So determining atomic structure. We talked about this in the last vodcast. Here's another way that we could do this, and I give you a chart, and you have to fill out the chart. So the element or ion is here, and we haven't really talked about ions too much, but I'm going to introduce them here, and then we'll bring them back in later. Okay, so ion, remember, is a charged particle. It's charged, positive or negative. Element is neutral. Okay, so hydrogen. And you should have your periodic table in front of you. And if you don't, pause it and get your periodic table. All right, so hydrogen is atomic number is 1. Its mass is 1.008. And its mass number, remember we take this and round it to the nearest whole number, which would be 1. Okay, number of protons. Well, number of protons is equal to the atomic number, so that would be 1. Okay. And if we were to write this in isotope notation, it would be like that. If we were to write this in hyphen notation, it would be like that. All right, and I did this because we've got to figure out the number of neutrons. So remember, the number of neutrons is mass number minus protons. Mass number minus protons. So 1 minus 1 gives us 0. And hydrogen is the only element on the periodic table that has a mass or a number of neutrons that's equal to 0. Okay? All of the other ones have neutrons. This is the only one that doesn't. All right. Number of electrons is going to have to be neutral because there's nothing written here, plus or minus. This one has a minus, that's an ion. This one has a plus, it's an ion. But this one doesn't, so it's neutral. And if it's neutral, positives equal negatives. So if we have one positive, we have to have one negative. All right, now arsenic, As is arsenic. Okay, and arsenic has an atomic number on your periodic table. If you see it, it'll have 33. Okay, whole number. All right, it also has an atomic mass that's equal to 74.92. Okay, so if we round this to the nearest whole number, our mass number should be 75. All right, now how many protons does it have? Well, it should have the same as the atomic number, so 33. How many neutrons does it have? Well, to find neutrons, we take mass number minus atomic number, and that would give us 242. Hope my math is right. Check it. Okay, now, it wants to know how many electrons. If it's a neutral atom, it should have the same number, but it's not neutral. How do we know? Because there's a -3 there, which means, when you see this, that there are 3 more electrons than there are protons. So if we have 33 protons, we have to have 36 electrons. Hopefully I didn't blow anybody's mind. Okay, let's try another one. We have H+. Okay, atomic number, it's hydrogen, is 1. The atomic mass is 1.008, and the mass number is 1. It's all the same, right? How many protons? 1. How many neutrons? 1. That never changes. Okay, well, at least up to the protons. I did that wrong. I'm sorry. This should be 0. It's just like the top one. Miss Ruark. Oh, see, I get so excited when we do this, and I just, ooh. Okay. Proton number 1. Neutrons 0. Electrons. Well, if it was neutral, it would have 1. But look here, it has a plus. And so it's saying that there's one more plus than there is negative. So if we have 1 proton, we have to have 0 electrons. Okay, hopefully I didn't blow your minds, and we're going to practice more of that in class. All right, so what can we do with isotopes? One of the things that we can do with isotopes is we can calculate the average atomic mass of an element using the isotopes. Okay, so there's a couple steps you follow. First, if you're given a percent abundance, you have to change it to just a relative abundance, which is decimal form. So how do we get from 99.35%? Well, we move our decimal over 2 times, right? And so we end up with 0.9935. Hopefully you got that. Okay. If not, we're going to practice. Okay, number 2, we multiply the abundance from step 1 times the mass of each isotope, and you'll get the mass of each isotope. And then once you get that, then you add it all up. Okay, so let's practice this one time before we go. It's not supposed to say example. That's so silly. I'm having all sorts of difficulties on this one. I promise the next one will be better. All right, rubidium has 2 common isotopes. We have rubidium-85. I'm going to write this out. And rubidium-87. Okay, if the abundance of rubidium-85 is 72.2% and the abundance of rubidium-87 is 27.8%, what is the average atomic mass of rubidium? Okay, now, if they don't give us a mass of rubidium-85 and a mass for rubidium-87, sometimes they do, then we'll use the mass number. So step number 1, we change this into a decimal. So we move our decimal over 2 times 0.722. And this one becomes 0.278. So good. So far, so good. All right, now we need to multiply what we've just done by the mass of each. Well, this one has a mass of 85. This one has a mass of 87. And so now we do the math. So get your calculator out. I know you're sitting there waiting for me to do it. Don't be lazy. Pause this and go get your calculators. And then come back and do the math with me. Okay. I'm waiting for my calculator to pull up. There we go. All right. No, I don't want to rate it. Okay. 0.722 times 85. And that gives us 61. Oh, goodness gracious. No, thank you. All right. 61.37. And then we do 0.278 times 87, and that gives us 24.186. Okay, now we add those two together. So let's add plus 61.37, and we get 85.556. Okay, and then the answer would be AMUs for our unit, atomic mass units. All right, so here, this is our answer. And look, it's between 85 and 87. I'm sorry, my dogs are going nuts. This is the best podcast ever. Okay, so, and the way to check this is if you look on the periodic table and you can look for atomic mass of rubidium, and it should be pretty close. Okay, all right, and there you go. I'll see you in class.